I'm Anil Kumar, and in this video we'll explore how to find different permutations in cases where we have identical items. To begin with, here is a question. Find the different permutations for the letters of the following two words using tree diagrams. So we have word TOM, Tom, another one MOM, mom. Both these words have three letters, but here is a difference. These three letters are unique, and here we have two repeating elements which are M and M, right? So we have identical elements here in the second case. Let us see how the permutations are different for these two cases. So let's make a T diagram. Let's start with Tom. So you could either begin with letter T or you could begin with O or M, right? So these are three starting positions, and then you could have, if you start with T, in the word you can have the letter O or M. Same is the case when you start with O, you could have the letter O or M, T or M, and for the second case, T or O, right? So you get a word with two letters. Now the third letter could be, in this case, if you take O, then you're left with M, and if you take M, you are left with O, right? In case of starting with O, if you take T, you're left with M, and if you take M, you're left with T. In this case, you're left with O or with T. Now that gives you combination of letters. Let's write down these letters. So we have TOM, Tom itself, then we have TMO, then we have OTM, OMT, MTO, and MOT. So we have 1, 2, 3, 4, 5, 6. So we have 6 unique words, right? They may or may not have meanings. We are not concerned about that. But what we have here is 6 unique words which can be formed from these 3 letters. Now what you notice here is that number of letters N in this case is 3, right? And the result is 6, which is N factorial, right? Which is 3 factorial. 3 times 2 times 1 is 6. So that is the result in our first case when the letters are unique and the elements are not repeating, right? So that is the case. Now let's do the same thing for the second word, which is mom. Here we have two M's. Just to differentiate between them, what we will do is we'll consider one as M1 and the second one as M2. Let's make a tree diagram. So we could have either M1, O, or M2. And then if we select M1, we have choice of choosing O or M2. If we take O, then it is M1 or M2. If we take M2, the choice is M1 or O. Now if we have already taken M and O, we are left with M2. In this case, we are left with O. In this case, we are left with M2. Here we are left with M1. In this case, we are left with O. And then we are left with M1. Now that results into how many words? Let's write them down now. So what we have here is M-O-M. So I'm not writing M1 and M2 now. I'm just writing the words themselves. And then we have M1, M2, which is M's basically, MMO. And then we have O, MM. Then we have O, MM. And then we have MMO and MOM. Now, what do you notice in this? You notice very clearly that some words are repeated, right? So what we have here is, like these two words, mom and mom repeats, they are not unique combinations, right? So these two words repeat, And similarly, we have two other words repeating, which is OMM and OMO also repeats, right? So what we see here is we are left with one that makes two and three. Three unique combinations, right? So what we get here is, as a result, three unique words. So out of these six combinations, 2, 2, 2 are repeated. Therefore, we have three unique words here. Now we could say that in this particular case, n is equal to 3, and since the letter m repeats, so we are saying that letter m repeats two times, right? So there are two m's. So number of permutations in this case are n factorial divided by 2 factorial. That is 3 times 2 times, because there are three letters, 3 times 2 times 1 divided by 2 times 1, that gives you 3 as your result. So three unique words you could get from this particular formula. Now there is a short formula which you can always use to find the permutations with identical elements, which you can derive from here as a result. So if there are n different words, let me write down here, and if out of these n different words a are of one type, in that case we'll have n factorial over a factorial. If there are b with another type, then b factorial, and so on. So that gives you a general formula for number of permutations where we have identical elements to deal with, taking all of them together at the same time. So I hope this example helps you the concept. We'll now use this formula and find permutations with identical elements. I'm Anil Kumar. You can subscribe and learn more from my videos. Thank you and all the best.